Hi there, here's a video tutorial about how you could handle archery soldiers with Golaem. So I'm running Golaem 5 right now, and here's the setup I'd like to build during this video, where I have characters in the foreground, throwing arrows to characters in the background, and those guys there collide with the arrows and just fall. Here's a really super quick overview of what's happening in the scene. So I'm having three types of people there. The soldier in the foreground, which are just playing a throw arrow motion clip. Then I'm having the arrows themselves, which are actually crowd characters. Here I'm using the master slave behavior to make them slave from the character, and at some point I trigger some physics behaviors to make them fly and collide with the different characters. And speaking about the background characters, I'm having a third entity type here, where they're just playing a walk animation and a reaction to a collision. Obviously, I also set up a bunch of triggers, but first, before getting into the behavior stuff, let me show you how to set up the assets, so how to set up the characters and the soldier characters and the arrow character. So let's first speak about the soldiers characters. So here into that video I'm going to use the fortress soldier character, which comes into the Golaem assets. So if you haven't downloaded the Golaem assets, go into the same place you downloaded the plugin and you will find a zip with the Golaem assets. So there's two different things I want to do here. I want to create one soldier which will be an archery soldier, and I want to create another type of soldier which will be an infantry soldier, but I want to define some specific physics properties on it. So first let's start with the archery soldier, the one which will be used in the front ground here. So let's take a look at the fortress soldier Golaem character file. So here's the skeleton representation, but the part I'm the more interested in is the geometry part of the character. So if you take a look at the already existing rendering types, there's mostly sword characters, saber characters, spear characters, and a banner holder. So obviously here I'd like to create a new rendering type, which will be the archery rendering type. So first click on the rendering type tab, press plus, enter a name for the new rendering type. Sorry about that. So here I'm gonna create a new type which will be archery soldier. Okay, so it's giving me the list of all the meshes which are available for that characters. Everything is set up to 50, but it's really up to me to define what do I want into my character. So I don't want to have any swords, so let's remove the swords group. Don't want to have any shield neither. I don't want to have any spears. Helmets are okay. And speaking about bow, here there's an empty choice into the bow, which means your characters will have either that bow or nothing at all. As here I want to create archery soldier, make sure to put that empty value to 0. And speaking about quiver, I may want to have all of them to have a quiver, so let's remove the empty value here as well. So here I've created a new type which will look like an archery guy. So let's save that character file as a new variation of my soldier. So I'm gonna call that fortress soldier archer and save it. Okay, so that's first part of it. Second part of it is here my character. In terms of physics properties, when I'll do my sim, I just want some piece of my characters to be hit by an arrows and influence my characters if they hit. So typically here, if I change the display of my scene to physics shape, I just want the upper part of the body when it's hit by an arrow to react accordingly. So I want to color those into the character file and save that along, so I can use that to filter collisions afterwards. So let's go back into my character file and into my character maker, into the skeleton properties, and you can see here there's something called edit physics properties. So as soon as you press that button there, you should have a display with the different meshes which compose your rigid body envelope for your character. So here's the default setup for that character. So what I want here, I want my characters when it's hit in the head. So let's take a look at the different names. So that's something called head, or in the neck, or in the chest, or into back A. So what I want to do is color those pieces of my character into the character file definition. So let's find my different mesh. So here's the head. If you go at the complete right of it, you get something which is called an attribute, which is called color. By default, it's just gray. So here I'm gonna change it for the head to, let's say, red. Make sure to change the alpha channel as well if you want to display that color at the end of the character. So let's increase the alpha channel there. I want to also change the color for my neck mesh, change the alpha channel as well. Also the chest, which is here, put it red, alpha channel. And finally change it for the back A. So it's really up to you. Oh, what about alpha channel as well? So it's really up to you to decide which color on which bone and filter collisions depending on this. Press apply, okay. And now I'm having my characters, which is now colored in red. So let's save that file again as a variation of my fortress soldier. So there's going to be a fortress soldier. Let's call that infantry. Okay, so now let's take a look on the arrow character. So it's just a dirty asset I quickly made, which is made of two meshes. There's a cone for the head of the arrow and a cylinder for the body. And those two meshes are skinned on 3 joints. So here's the root of my skeleton, which is at the bottom of the body, and the last joint is that at the up of my head. So the main reason why I created 3 different joints is because I want to be able to set up different properties into the physics properties of my characters for the head and for the body. So let's take a look at the Golaem character here. So let's jump into the character maker. Here are my 3 joints, and the way I map it into the skeleton tab is I created a root bone to store the root bone of my arrow, and then a spine to store the joints for the head. So once again, the main reason for this is because into the physics properties I want to have 2 different lines, one for the body, one for the head, in which I will specify different properties. So speaking about properties, here I changed the shape to cylinder with different sizes, which means I'm having a bigger head and a smaller body. Obviously, I also set up the joint limit to 0, so I make sure that the arrow is not going to bend. And the final important parameter I wanted to set up are the damping. So damping is the coefficient at which a rigid body loses energy during the simulation. So the higher the value and the faster the rigid body will lose energy. So here into the body of my arrow, I put that value to 1, which means it will lose energy almost at the beginning. And then for the head, I put a super small value, which means it's losing really small pieces of energy at each iteration. Which means here I kind of reproduce the kind of simulate the thing that here the head of my arrow will be super heavy and it will control the direction of my arrows. So make sure to put the body or the lighter part to big damping value and put the heavier part to some small damping values. So okay, I'm super happy with that, and now I can jump into simulation. Well, let's start from a brand new scene and try to reproduce the same setup I showed you at the start of the video. So the first step here will be to create my entity types node. So I will have an entity type for the archery guys, one for the arrows, and one for the infantry guys. So click on that button here, create an entity type node there. So I'm gonna set up the character file first. So I'm gonna define my archery soldier. I'm gonna actually rename the node to do that properly. So this is my archer character. So load the character file in it. Define the way it's going to be displayed. So I want to display it as render previews, and it will be double-sided. Speaking about rendering attributes, here it's going to be my archery guy. So I want to make sure to use the rendering type I created earlier, which is the archery soldier type. Add it there, and remove the default one which has been added. And here it is for my archery guys. So let's create a type for the arrow now, and I'll rename the node as well. So it's going to be the arrow character. Load the arrow character file in it. Change the display mode, so it's going to be render previews. The rendering type is correct. And one thing which is super important is that I'm going to use the arrow as a slave of the archer. So to make sure that both position and orientation will be correctly read from the archer, I want to say to Golaem that that character here need to be updated before that character there. So I can go into the advanced attributes, and I can check for the master slave level attributes and change this value. So by default, all the entity types, they have the same 0 value. And if you want one entity type to be evaluated after the others, you can just increase that value. And let's say you will have a slave to the arrow character. You can go into its master slave level and just put a value which is bigger than that one there. So that's for my arrow character. Then finally, let's create my infantry character. Rename it as well, infantry character. Load the character file. I created the one with the colors in it. Here I want to use physics shape, so I will be able to show you the colors of the different rigid bodies. The size is correct and the rendering type is correct. So okay, next step, let's create a population tool and create particles into the simulation. Here I'm gonna use the standard population tool, the grid one. Just click anywhere into the viewport, creates a new locator in the scene, and you can increase the number of characters you want to have, change the size of the grid, etc. etc. So first I want to set up my archery characters and my arrows. So I don't need that yellow character here, which is the infantry character. So I can go into my population tool and remove it from the entity types attributes. Second thing which is super important is you always want to make sure that you have the same number of arrows than the same number of archers, else you will have archers without arrows, or if you have more arrows in your scene, you will have several arrows for the same archer. So you want to make sure that here this is 50-50 and the number of particles is actually even. We're gonna start small with just 10 characters here. So we can properly set up everything, and then when we'll be happy with that setup, we'll just increase the number of characters. Change the distance between the characters, and when I'm happy with that, I can just create a new population tool, a new particle system. And if I rewind my sim and play a couple of frames, I should have my characters popping into the sim. So green guys stands for our archery soldiers, and blue guys stand for the arrows. You can see that they're assigned with the correct geometry type. They all have a bow mesh and the quivers. And the final thing I'd like to do is maybe changing the size of my arrows, because here they're way too big for the character. So I'm gonna go into my arrow character entity type and into the scale min, scale max. I'm gonna reduce that a bit, so it will look like some more, than arrows. Better. Finally, let's load the shaders, because here they're all orange. So let's fix this. Go into the Golaem render menu, import crowd shaders. Yes, please. Go into the character pack, which is there. And if you look into Golaem shaders, you'll have a file which is called Fortress Soldier. It will load a Maya file, which is the loop dev of the character. it will put that into at the origin of the scene, and let's hide it for now. But as soon as it is in the scene, you can just go into your entity type and ask the GPU display to be refreshed, so it will reload the geometry and reload the shaders according to what's in the scene. So now I should have my characters skinned. Okay, so let's go into the behavior step. Go into the behavior editor and we'll start setting up the behaviors for the archer first. So double click on the archer entity types, opens the container of it, and we just want our archery guys to play the throw arrow motion. So we're just going to use a motion behavior, double click on it and load motion clip. If I take a look to that motion clip here, that's just a guy taking an arrow in his quiver and just throwing the arrow. And let's take a look at the sim, play the result. So I'm having all the characters playing that motion. So, okay. The first thing I want to do is remove the fact the motion behavior is looping. So I'm checking the loop box. So they'll just play the motion once and stay in the same posture. And they're all playing the same frame at the same time, so I can just randomize a bit the stop person. So I'm just adding a tiny shift in the way they start in the way they play the animation. That's better. So that was it for the setup of my archery character. Now let's set up the arrow character. So let's go into its container. The first thing I want to do is specify that it's going to be slaved to my archery character. So I'm going to drag and drop a master slave behavior, put it into the flow, and start configuring it. So the master entity type I'm going to use here is going to be the archery entity type, and then I can specify what's going to be the bone to which the arrow will be attached. So let's open the helper, and I'm pretty sure there's something called wrist on my character, and my bow is on the left wrist. So I'm going to attach the arrow to the left wrist. If we just play the sim, you should get the characters playing the animation, and as you can see, the arrow mesh is just following that wrist. Obviously I want to change the offset there. I want to change first the orientation, put minus 90 degrees here, I guess. Yep, that's better. And maybe constraining, adding a position offset as well. I guess 0.9 something there should do it. Yep, that's a bit better. It's along the arm. I can shift it a bit so it's on the exterior. 0.15 there. Okay. Obviously, you could. It will be better to attach it to the ray trace, so you'll have it out of the quiver and that kind of thing. But here is just a quick and dirty way to show you how that works. So I'm pretty happy with that. Let's now try to get the arrow thrown as soon as my characters hits a certain posture. So you can see here is the characters at some point is just releasing the bow. So if I click on that guy, you can see he's releasing around 68% of the animation. So what I want to do is I want to say to the arrow that as soon as the master character reach that posture, so 68% of the animation, I want to play a different behavior. In here, in terms of different behaviors, I want to play physics behavior to be able to throw the arrows. So I want to add onto my arrow character an attribute behavior. So that attribute behavior will be used to fetch the value of my motion ratio from my master and use it elsewhere. So I'm going to go into the attribute behavior here, create a new expression. So it's asking for a PP attribute and an expression. Let's first create a PP attribute. I can use the Swiss knife tool here to create a PP attribute. So I want to have a PP attribute called master ratio, which is going to be a floating value. So I just pressed float, and now if I go to my particle system into the attribute editor. I should get a new PP attribute which is called master ratio. So let's use that one into the attribute behavior. Use the name helper master to retrieve the same name, copy, paste, and I'm gonna use a channel as an expression, so I can use the channel helper as well. And I want to fetch a ratio from my master character. So you can see here there's a channel which is called this, which stands for which entity I should fetch the information from, a name of the behavior, and current ratio. So I want to use this, put it here. Here I don't want to fetch the value from my arrow character, I want to fetch it from the master archery character, so I can use a keyword which is called master, and here it will just refer to the direct master for the current master of my entity. Then a behavior name, so let's go back into the archer, take the name of the arrow throwing motion behavior. So copy here and paste it there instead of the behavior name tag, and remove this, and the current ratio, which is a keyword. So it means that when I throw the sun, pick an arrow, now I can see into its visual feedback that it's playing the master slave behavior but also the attribute behavior, and you can see now the motion ratio is actually increasing, so it's storing where is this character in the animation. And at some point when I reach that 68%, I want to play a motion behavior, physics behavior, sorry. Then let's set up that physics behavior. So here I can drag another behavior, which is the physicalized behavior, to specify that my character will enter the physics word, and I want that behavior to change my characters as a dynamic rigid body, which is let's say ragdoll, and I want to change that state for my character when I reach that ratio of 68%. So I'm going to change the stopping trigger for my physicalized, double click on the stopping trigger. By default the stopping trigger is set to false, which means that behavior never stops. But I can use the PP attribute trigger, set it as a root, so that's now the new stopping trigger, and specify what's going to be my PP attribute I want to fetch for. So here it's going to be master ratio, and I want to start that behavior as soon as I reach the 68% value of the motion. Let's take a look now how it looks like. And you can see that as soon as I reached that posture, the arrow character just went physicalized and just to fall on the ground. So let's add a force now next to it. I want the ragdoll then to be influenced by something, so I can add a force behavior, which will just apply a force on the arrow, so you'll be able to set up how far does it go and in which direction does it go. So I just put the force next to the physicalized, so first the arrow went into the physics word and then a force is applied. So I can change here the magnitude of my arrow, and I can also specify what's the direction. So here I'm going to use the character relative, so depending on the orientation of the character you will go into some of the direction. So here I want to go up, so I'm going to use the y-axis of my character relative to specify in which direction I want to go. And if I just throw the same now, I'm having my arrow characters, and as soon as the character reached that posture, the arrow characters went physicalized, and it's just applied with a force. So let's play it again. Pretty neat. And as we set up correctly the damping on the head and on the body of the arrow, it reacts accordingly, so it does a pretty nice curve. So let's change a bit the magnitude, reduce a bit the magnitude, so I'm adding something which is less powerful. Okay, so that's the setup for my archery guy. So now let's set up my infantry guy. Setting up the infantry guys is quite the same process, which is First, populating the scene, so creating a new pop tool, put it here, increase the number of characters and rotate it a bit. I just want to have infantry characters here, so I'm going to change the entity types attribute, remove the archers, remove the arrows, and maybe changing a bit the distance between the characters, orientation a bit, and noising position. Okay, when I'm happy with that, I can just create the new particle system, and if I play the sim, I should get my characters popping. So if you remember, when we set up the infantry characters, we defined their display mode to physics shape. We can even change to render previous to see how they look like in terms of geometry. If I pick the physics shape mode, it's because I wanted to show you the filter we've been defined, the colors we've been defined on the rigid body. So you can see the characters is yellow, but not on the neck, the head, and the chest where we define it's going to be red. And we're going to actually use those to filter collisions. Let's say an arrow hit the shield of the character, or maybe the legs. You don't want the characters to fall and to be physicalized. But if it takes an arrow in the chest or in the neck or the head, you want them to react. So let's take a look at the behaviors for the infantry characters. So I'm gonna first let them play a motion, just a walk motion from here, like a walk normal animation. So it's not especially a soldier animation, so I may have a collision with the shields, but yeah, this is just a walk. Once again, if you got the correct asset, that will be way better. Then I want to define physicalized behavior. So once they get hit by an arrow, they switch to the physics mode. And here I want to define when do they switch to physics mode. So I want them to collide with an arrow. So I'm bringing a physics collision trigger, set it as a root, and I want that the collider is in, so the collider is going to be the arrow, so I want it to be dynamic, so in ragdoll mode, and I want to filter it by entity type color. So right now my arrows, there are where are they? My arrows should be blue, I think. Yep. So let's, yeah, okay. So that's my arrow. So I want to filter by the color of my arrows. So I want to specify that, okay, when I hit an entity type which is blue, I want to fall. So if I run the sim, each time a character hits that blue stuff, oops, yeah, it falls. So there was one guy at the bottom who took an arrow in the head. You know what? Let's put those guys a bit different position, so they are more into the arrow, and replace the particle system. Okay, let's do it again. So there are no filters by chest right now. As soon as they hit an arrow, they just go ragdoll. And I actually want to combine this with, if I collide with an arrow, I fall, but also if that arrow hits a red part of the body. So I'm going to bring another collision trigger here, where I want that the collided, which is the infantry characters, is bone color is actually red, and I want to combine those two. So I'm going to bring in an AND operator and say, okay, I want to, at the same time, I want to collide with an arrow, and I want that arrow hits a red part of the body. So now you should have that only the characters hit by arrow should be hit by an arrow in the chest or in the head or in the neck should be influenced. Okay, better. So right now they're just playing ragdoll, so they're just falling on the ground. But obviously it will be way better to play correct animation, like a dedicated animation of a guy taking an arrow and falling. If, I don't have that kind of animation right now, but if you have that kind of animation, you can just play your physicalized behavior instead of playing it with dynamic. You can just use the local servo rigid mode, rigid body. So it means that you're gonna play at the same time the physics with all the collisions detection and collision reaction, but at the same time also play a motion clip. So it will be just a way to enhance the way it reacts and the way the simulation acts. So the last thing I wanted to do here is, you may have noticed that the arrows that just fall on the ground, they just slide on the ground. The last thing I wanted to do is stop the arrows when they hit the ground, just make them go through the ground and plant into the ground. Plant into the ground, I need to first define the ground, obviously. So I'm going to create a box here. And well, just a side note, when you use physics and you want to define colliders, it's always better to use volumes because it's the collision detection is going to be more accurate. If at some point you have defined a surface instead of a volume, one way to have accurate collision detection will be to increase the physics solver substeps, so add more substeps, so collision detection will be more accurate. So here I'm using volume, so that's not going to be a problem, I guess. And I want to set that volume, change its position a bit, so it's right at the same level than the grid. Change its size as well, so 100 should be fine. And what I want to do is, as soon as I want to define to my arrows that as soon as they're going to hit that cube, I want them to be dephysicalized. So I want to create this cube as a collider, so I select that cube there and click on that icon here, which creates a crowd rigid body out of the selected geometry. So I'm having now a new node, which is a crowd rigid body node, in which you can define what's the rigid body attribute, so what's the bounciness and the friction, and what's the mass of it. I can also define what's the shape, so it has detected it's a box, so it set it as a box, but you can use convex L or triangle mesh if you have a more complex mesh. Here I'm going to stick with the box. It also has some physics collision attributes, which are super handy if you want to filter collisions with rigid bodies. So let's say you have several different rigid bodies in your scene. You want to maybe you want to react differently according to the different rigid bodies. So you can have different IDs here, and into your triggers you can filter collisions. So here I'm going to give a random collision ID, which will be 10. And I'm going to say to my behaviors that as soon as my arrows hit a rigid body of ID 10, it's going to be dephysicalized. So let's close those there and figure out what to do. So we can add a new physicalized behavior and put it next to the force. So I'm having my behavior here. As soon as my master ratio hits 68%, I'm going to go to the force, and the stopping trigger, default stopping trigger to the force behavior is set up to false, which means right now it's blocking the signal, and we're going to change that a bit later. And then we need to go into the physicalized behavior and set it up to dephysicalize, which means the arrows will go out from the physics world. They will not be physically simulated anymore. I want to change the stopping trigger as well. So by default it's always false, so I want to set it to true, which means it just go through in the same in just one update. It will enter, set up the status to dephysicalize, and then go out. And the final thing I want to set up is my stopping trigger for my force. So right now it's set up to false, but what I want to do is I want to change this as soon as I hit my rigid body of ID 10. So I'm going to bring a new physics collision trigger, set it up to collision mode to crowd rigid body collision ID equals 10, and as soon as it's going to hit it, it should just go out of the physics world. So let's throw again the same, and I'm going to catch an arrow just to check what's going on here. Okay, and let's check the behaviors there. So right now it's playing the force because it hasn't hit the ground. And as soon as it hit the ground, you've noticed that it has exited the force behavior and went through the physicalized node into one frame, and we should have it. Okay. Okay, that's my mistake here. Actually, so it's going here. That has been configured correctly, but the problem is the master-slave behaviors is still running. I haven't stopped it yet. So it means that as soon as the physicalized behaviors are not played anymore, the master-slave gets the control back on the position and orientation of the object. So I actually want to deactivate that master-slave. So when I actually define my ratio of 68%, I actually want to stop my master-slave with the same properties. So I want to create a pp attribute here, set it as a root, and here as well I want to stop as soon as my ratio master it's 68%, well, more than 68%, and that should do it. Let's run the sim. So they throw, and as soon as they hit the ground, they just stand themselves and replay the default posture. So that's not exactly what I want to do. I want to lock the posture, so I want to change this into my physical behavior. You may have noticed that there is an option which is lock posture and stop, which, as the name tells, as soon as that behavior stops, it just freezes into the current posture. It's actually grayed out. It's just a bug into the interface, so I'm just gonna fake it here. So I'm going to physicalize local servo or whatever, which allows me to check that box, and I can go back to dephysicalize. And then now I'm having set my arrows to lock postures on the final frame, and when they hit the ground, it just freezes into the current posture. So it's not always exactly what you want. So you may have to tweak it a bit, just apply and change the forces to have exactly what you want, or maybe change the collision triggers, but that's already good for what I need here. So as promised, let's add more characters here, increase that. Let's say, okay, I want to have a 10 by 10 field, and let's add a even number of characters, let's say 150. Maybe reduce a bit the grid. Okay, I'm having just, yeah, my mistake. Something like 64, yeah, should be fine. I want to replace the particle system here, and throw the sim. Oh, that was hard. Ah, yeah, I know what it is. So we have emitted new characters, and as I told you, you need to have an order in which, in the way the arrows in the archer must be updated, such as you need to have an order between the behaviors. So here, my attribute behaviors is looking for a master, but sometimes, as they are in the parallel operator, all those behaviors run at the same time. But sometimes, depending on multi-threaded option you may have, your attribute behavior may start before the master slave, and may have error messages saying me that it couldn't find any master. Yeah, so as you can see, it says, okay, I couldn't find the master channel. So what you want to do is you want to delay the start of your attribute behavior. You don't want to start the two behaviors at the same time. So you can either change the starting trigger of this, or you can add just a block operator in front of it, and just add a couple of frames, like let's say 2 frames. That should be it. So here I'm having all my branches here starting at the same time, but that attribute behavior will be blocked a bit by 2 frames. So the master slave behaviors has the time to start before, and then the attributes has the time to hook up once it's been started. So it's still running. So let me check. Force attributes, master ratio. You can't read it. Oh, okay. So I may have to recreate the particle system from scratch. So let's delete this, pop tool, create a new particle system, and onto that particle system I want to recreate the master ratio and relaunch the sim. Okay, so now that's better. And I'm having, yeah, more characters hitting my my infantry guys and falling. So I hope that it makes sense. The rest of the workflow is pretty same. You can then export the sim, and once the sim has been exported, you can switch into the layout mode and relay out your sim or edit whatever you want to, or even render your crowd. So export to cache, go into sim layout, and into that process I should see my simulation going on. So hope that it makes sense, and see you in the next video.